Hello, hello. The question is, how do you find the length of an object in the 3D space? What is the length actually? For example, if you want to find the length of a bone, if you want to place the locators or the joints in the right position, the first thing you need to know is that the thing is essentially long, right? The humerus bone is long. It's like a stick. So what would you do? One way is to iterate through all of the vertices and then find the vertices that are the furthest away from each other, which is something like this, right? It's pretty fast. I'm using NumPy. You could also use the regular my Python math library, which is a bit slower. NumPy is a bit faster for that one. The third option would be to use a machine learning library like PyTorch, for example. So what does it do? It iterates through the vertices, generates locators at these vertices, and then it just moves these locators just a bit towards each other, right? So I can, when it's not placed properly, I can change this. It's down here. Move the locators towards each other by a certain distance. Let's see, let's set this to 3, for example. And run this again. Yep, so now they're a bit too much. Let's pick ones. But as you can see, it's not super accurate, right? So what else can we do? Another way was to use something like this. So this is a visualization of what this bone rigging system does automatically. First, it finds the highest vertex in the Y space, right? So for example, wait, I have to go back. Finding the highest vertex, right? It's here. It's the highest vertex in the Y space. Now the lowest vertex in the Y space, right? Essentially, that's already the right spot. However, not really. You have to think of this as a 3D space. What if it's like, oh, how do I explain it? I think you get it. So then you can find the rightmost locator, leftmost locator, the front locator, the back locator. And then what it essentially does, it creates like this mesh kind of thing. This is these lines, what's it called? Like a proxy mesh, in a sense. But I visualize this using these lines, And then you can also calculate the distance. So then it finds the longest line. It finds the longest line, and it leaves only the longest line, or it can also leave the shortest lines, right? Both, right? Then what it does, when I have both of the lines, the longest and shortest lines, it finds the middle point of this. It creates a plane, right? But right now it doesn't work. But then it creates planes where these things are, right? So it then finds the center of this triangle here, right? Also the center of this triangle here places a joint in the center, also here, and then it sets this longest line to the center and moves this towards each other. I really should have coded also this in, but I did it really quickly. I have it in my rigging code, so this is like just a visualization demo. But yeah, overall it works fairly fine, I think. That's how I solve these problems. There might be way better solutions than there probably are. So for this, again, wait, select this again. That's really inefficient, quickly made code, but boom, 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 bow, and create lines, creates a proxy mesh, and leaves only the longest line, and creates also these triangles and places these in the right position. Let's see. So it's not accurate, actually, This triangle here, it would place it like somewhere around here, I think. So the best way is to use a combination between this vertex selection code, probably. But it's like remove. Okay, I group these. I'm gonna hide these for now. And see? So, yeah, as you can see, it's not as efficient. That's the best I can do for now. Finds the fairly good approximation for the placement of the joints. So that's how I solve this problem. If you guys have any better ideas, please let me know. It's really interesting for me. Right now, I'm trying to get this to work in a really efficient way to have any kind of skeleton and generate everything automatically.